All right, here's quiz 2 solutions. Question number 1. We start out, we're being asked to use the difference quotient to find f prime of x. To save a little time, I wrote the difference quotient up here. It's the limit as h approaches 0 of f of x plus h minus f of x over h. Something that hopefully everybody had memorized coming into the quiz. So to find f prime of x, really all we do is evaluate this expression using f of x is 4 over x. So if f of x is 4 over x, f of x plus h is going to be 4 over x plus h. And from that we subtract f of x. And we divide this entire thing by h. This is the limit as h approaches 0. Unfortunately, we can't just plug in h equals 0 or end up with 0 over 0, so what we have to do is find a common, we have to simplify basically and cancel out this h. And the way we'll do that is by first finding a common denominator in the numerator. The common denominator in this case will be x times x plus h. So what we do here is we multiply this side by x over x and this side by x plus h over x plus h. Since both those are equal to 1, we're not changing the answer at all. So if we simplify a little bit, we get that's equal to the limit as h approaches 0 of 4x minus 4 times x plus h, all divided by x times x plus h, our new common denominator, and all that is divided by h. Sometimes it's helpful to think of this as h over 1 so that we have a fraction inside of a fraction. That'll end up being easier later on. What we do now is distribute this negative 4 through, which gives us 4x minus 4x minus 4h. Common mistake was to leave this as plus 4h, but remember it's a negative 4 that you're distributing through here. In the denominator, we could distribute the x, but there's really no need to, so maybe I'll just leave it as x times x plus h. And this is all divided by h over 1. Again, this is the limit as h approaches 0. So the nice thing that you might be able to see at this point is that we have 4x here and minus 4x here, so those guys cancel out, which is good because canceling out those will enable us to cancel out the h's, as you'll see in this next step. We got that's equal to the limit as h approaches 0 of, what do we got, just a negative 4h left up top, and then x times x plus h. And then instead of dividing by h over 1, we'll multiply by 1 over h. Remember, dividing fractions is the same as multiplying fractions, except you have to multiply by the reciprocal of the denominator. The advantage to looking at things in this form is maybe now you see that this h right here and this h right here will cancel each other out, which is good because now we won't end up with that 0 over 0 when we plug in 0 for h. So if we multiply this through, we get the limit as h approaches 0 of negative 4 divided by x times x plus h. This is a limit we can evaluate directly by plugging in 0 for h. And what we'll be left with is negative 4 over x times x plus 0, which is just x times x, which is x squared, which is our answer. Moving on to part B. We're asked to write the equation of the tangent line to f of x at x equals 1. I rewrote f of x down here just so we'd have it handy. The equation of the tangent line will look something like this. We need to figure out what m is and what b is. And usually the easiest way, or one way to get it into this form, is by using what's called point-slope form, which I wrote over here. So what do we need to know? We need to know m, y1, and x1. Some of those things are given, some of them are not. Maybe m is the hardest. M is the slope, which is the derivative of the tangent line at x equals 1, so it's f prime of 1. which you can recalculate using the definition of the derivative or the difference quotient, or a much easier way is to use our answer from part A, where we figured out that f prime of x was equal to negative 4 over x squared. So therefore f prime of 1 is equal to negative 4 over 1 squared, which is just negative 4. To get our point, we want to figure out x1 and y1. We're given that x1 equals 1, so we need to know what y1 is. The way you figure out the y value for a corresponding x value is by plugging it back into our original function here. Since f of x is equal to 4 over x, f of 1 is going to be 4 over 1, which is just 4, which is what we will call y1. So now we have all of the pieces to plug into this formula. See, y minus, instead of y1, we can write 4, equals m, which is negative 4, times x minus x1, which is 1. Now if we distribute this negative 4 through, be careful, negative 4 times negative 1 is positive 4. It's a mistake I saw a few times, people just distributing the 4 through, not the negative 4. And finally, to solve for y, just add 4 to both sides. Now we have something that looks like this y equals mx plus b. This right here is the equation of the tangent line at the given point. All right, moving on to question 2. Question 2 is an average speed question. So you need to know that average speed is the change in position over the change in time. You can think of it as the slope of the secant line for these two x values, t's in this case. So more formulaically, it's the change in our y value, the g of t, divided by our change in the x value, t in this case, t minus 1. So what we'll need to figure out is what we want to call t1, what we want to call t2. Maybe we'll call this guy t1 up here, this guy t2. If you switch them up, it won't matter. You'll still get the same answer. Once we have that, we can figure out what g of t1 is. We know g of t equals this, so g of t1 would be 2 times 1 squared plus 3. 1 squared is 1, times 2 is 2, plus 3 is 5. Similarly, g of t2 we'll get by plugging 3 into our g of t. 2 times 3 squared plus 3. A little harder to do in your head. Let's see, 3 squared is 9, times 2 is 18, plus 3 gets you to 21. And now we have all the pieces to plug into our formula here. We can get our answer. We got average speed is equal to g of t2, 21, minus g of t1, which is 5, divided by t2 minus t1. Let's see, I guess that's 16 over 2, which simplifies down to 8, which is our answer. Moving on to part B. Part B, it says to use the definition of the derivative to find instantaneous speed at the time t equals 2. So what we want here is f prime of 2. Here's our definition of the derivative over here. F prime of a is given as the limit as t approaches a of g of t minus g of a over t minus a. You may have seen this with x's in there instead of the t's and f's instead of the g's, but I changed the variables so that it would match up with the problem that we're trying to solve. So if f prime of a is equal to this, f prime of 2 is going to be equal to the limit as t approaches 2. A few people had that wrong, kind of a common mistake that I saw, of the limit as t approaches 2 of g of t, which I now have written down here so we can see it's 2t squared plus 3 minus g of a, but our a value is 2, so g of 2, see, that would be 2 times 2 squared. 2 squared is 4, times 2 is 8, plus 3 is 11. Divided by t minus 2. If you simplify the top a little bit, you get 2t squared plus 3 and minus 11 turns into minus 8 over t minus 2. We can't just plug in 2's for t's or we'll end up with 0 over 0, so what we have to do is factor out the top. Saw a few different ways of doing this. Maybe the most clever was if you first factor out a 2 from the top, you end up with t squared minus 4, which is a difference of squares, right? It's t minus 2 times t plus 2. So some people factored it that way, pretty clever. Another way you could have done that is you know that there has to be a t minus 2 in the top somewhere, so that it'll cancel out with this t minus 2. So you can start by just writing t minus 2 up here and then figure out what we'd have to write here to get us back to 2t squared minus 8. To get the 2t squared, we'll want t minus 2t. To get the minus 8, we'll want minus 2 times positive 4. If you FOIL this all out, we'll end up with a 0t, so in fact it does check out. And the advantage to this one is now we have these t minus 2's canceling out, which is good because now we can evaluate the limit by just plugging in 2's for t's. The limit as t approaches 2 of 2t plus 4 is just 2 times 2 plus 4, which is 8. So those are the solutions to quiz 2. I'll post these notes on Blackboard so you can look at these for longer if you'd like. Hope that helps.